We have them in the room. They are automatic sprinklers. How many of you have them in your buildings? Everybody? Do I have a few that do not have them? Good. All right, so we all have sprinklered warehouses. And I guess, does everybody understand how they operate? Go ahead. How?
It's got a fuse link on it, so it gets to a certain temperature that goes and lets the water pressure come out.
Very good. That's it. Exactly how they operate. Are they supposed to extinguish the fire or control the fire? Somebody else, or I got to go to the same person? He answers all my questions. I give him free consulting. Somebody? Suppress the fire or control the fire? Control the fire. Anybody for suppress the fire? Yeah. Depends on the type of the sprinkler, and it depends on the type of the sprinkler systems. Some suppress the fire, some just are supposed to control the fire so that when the fire department finally makes it to your facility, they finally do final extinguishment. All right. I'm going to ask this question twice. I'm going to ask it right now, this question. Who feels confident that their sprinkler systems in their facilities are adequately designed? Raise your hands. Anybody doesn't feel confident right now? Okay, everybody's confident. I'm going to ask this question at the end of the presentation, and you got to be honest with me then. This facility was totally sprinklered with adequately designed sprinklers as we knew it back in 1982. 1.2 million square feet, fully sprinklered, totally destroyed by a fire in 1982. This facility thought they had state-of-the-art sprinkler systems in 1987. 200,000 square foot paint warehouse, fully sprinklered, totally destroyed by a fire. There's another picture of it. We're going to come back to this, and you're going to get to see videos of this one. Phoenix, year 2000. The facility thought they had adequate sprinkler protection. 100,000 square foot home and garden warehouse, fully sprinklered. Totally destroyed their side of the building, which is the left side of the picture, and took out their neighbor, which was a pharmaceutical distribution company on the right side of the building. Yeah, that's right. Sorry. 2004, Conyers, Georgia. My belief is that this facility never gave a thought to the adequacy of their sprinkler system. This is 260,000 square foot pool chemical warehouse. It was fully sprinklered, totally destroyed by the fire. And we will talk about this one in a little while also. And finally, 8 months ago in Texas, 100,000 square foot chemical warehouse and packaging facility, fully sprinkled, totally destroyed. This facility, they could have never known if they had adequate sprinkler protection because they didn't even understand the chemicals that they were dealing with. All right, so how can a fully sprinklered facility be totally destroyed by a fire? Come on, gave you the answer already. Here we go, my man here.
Fire department shuts the water off after a certain time.
Ooh. You'll see that. You'll see that with Sherwin-Williams, but it had no effect. It was already a done deal. No? Nobody is going to answer this? Come on. Inadequate sprinkler densities, inadequate sprinkler design, inadequate maintenance of your sprinkler systems. All things that even though the head is up in the ceiling like it is in this room, all things that could prevent either adequate water and pressure coming out of it or no water and pressure coming out of it, allowing a small fire to just go out of control. Also, with inadequate sprinkler design, are you okay? I hit that. I don't know if it did anything. Good. Okay, sorry. All right. Also, with inadequate sprinkler design, is that we've gone to a certain type of storing certain type products or a certain type storage arrangement that the sprinkler system can't handle. That's all in that package of inadequate sprinkler design. So what you should have learned already is just having those sprinklers in the ceiling does not assure that it's going to put out the fire. That there's way more to it. All right? It's the correct type of sprinklers supplied by the water pressure and flow. And it all depends on what type of products we're trying to protect and what type of storage arrangements you have in your facilities. If you remember that picture in the beginning that I had of the 3 sprinklers, there's a reason why they all look different. The one on the right is supposed to do suppression of the fire, is supposed to put the fire out. The other 2 are just control type heads. All 3 are for different occupancies, different storage arrangements, different protection of products. So automatic sprinklers are not one size fits all. So now, as I said, I'm not going to get technical. I realize the positions you're in. But you do need to know what causes or what issues could arise that could make what you think is your adequate sprinkler system all of a sudden become an inadequate sprinkler system. And as the owners, managers, supervisors, that is your responsibility. It's not your responsibility to determine is the sprinkler system adequate. It's just your responsibility to identify that perhaps I have a problem and perhaps I need to go to somebody else and determine if it is adequate or not adequate. All right. All products are divided into different classifications. With different classifications come different flow and pressure requirements for your sprinkler system. There are numerous classifications. If you store general commodities, there's 4 classifications. You store plastic products, there's 3 classifications. You store flammable and combustible liquids, there are 6 classifications. You do oxidizers, there's 4 classifications. It goes on and on. Rubber tires, rolled paper, they're all different classifications. Who has aerosols? Any idea how many levels of aerosol classifications there are? Gentlemen back there? Anybody know? How many aerosol level classifications? Nobody knows. There's 3. Let's go back to this fire. This is the Kmart fire. It was in Pennsylvania. It's from 1982. It was 1.2 million square foot distribution warehouse for Kmart. It's fire is coming up on its 30th anniversary now, June 21st, 1982. This fire was started when a carton of aerosol cans of carburetor cleaner fell and several cans ruptured, allowing flammable vapors to be ignited by a nearby electric lift truck. there was no separation between the aerosol storage and paint, flammable paint storage that they had in the warehouse. There was no containment for the aerosols, so anybody that is somewhat familiar with what happens when an aerosol can is involved in a fire, it rockets all over the place. And that's what happened in this fire. It started, the cans were rocketing all over. Quickly, the sprinkler system was overwhelmed. Very early in the fire, the fire was so intense that the roof collapsed. And there was no way they were going to save this building. This was kind of, in my industry, the fire protection industry, this was a very landmark fire, as you would want to classify it. From the standpoint of my industry quickly realized we didn't understand how to protect aerosols. At the time, we didn't understand that there was actually 3 classifications of aerosols, from the less hazardous to the extremely flammable. So this fire initiated a lot of technical research projects, a lot of testing, and then it kept going and it developed a lot of codes on aerosol storage. These are the codes that those of you that raise their hands that store aerosols should be following today. So the one question I'll ask then is, those that said they were storing aerosols, how many of you store them in a cage? Is that everybody that raised their hand on aerosol? Who's storing aerosols not in a cage? In a cabinet. Well, that's good. Or in a cutoff room's also good. There is one level of aerosols that you don't necessarily have to store in a cage. That's what they call the level 1 aerosols. But if you've got level 2s and level 3s and you have a substantial amount of them, you got to have some confinement for them. All right, product classifications can change with different packaging arrangements. This should be a simple concept to understand. You had a sprinkler system, you've been in your building for 5, 10 years, and you've been storing metal liquids in metal drums. And we know your sprinkler system's been adequate all these years, confirmed by your consultant, your sprinkler contractor, your code official, whatever. Now all of a sudden your vendor, your client, starts shipping you these liquids in plastic containers. You should be a little concerned then, is my sprinkler system still adequate? So you need to realize that when a product packaging arrangement changes, the classification could also change. That could also require then different flows and pressures out of your sprinkler system. And we're going to go to the Sherwin-Williams video. Sherwin-Williams just went through their 25th anniversary of this fire. This was from May 27th, I think, 1987. All right, this video is from local news station out in Dayton that looked back on the fire. It's got footage from the original fire. It talks with some of the firefighters and fire chiefs that were at that fire. It talks with them now 25 years later. It'll talk about flammable liquids and aerosols that were stored, which are natural in a paint warehouse. What it really highlights too is that that warehouse was built on the aquifer that provided the drinking water for 1/3 of the Dayton, Ohio residents. It's something now that when we look at, well, at least when I work with my clients and we look at new facilities or we do due diligence, we are always looking at where we could cause the environmental issues. We look at how close streams, creeks, lakes are. Certainly we would not, and I don't know that anybody now has ever built another warehouse like this on a aquifer. They'll talk in the video about their biggest concern was the contamination of the drinking water. But there is an underlying issue to how a rather small flammable liquid spill fire escalated to what they call this mega fire. What the video doesn't go in extensive detail on is that Sherwin-Williams thought they had state-of-the-art sprinkler systems in 1987 at this facility. Unfortunately, what they were doing, though, at the time was they were starting to package mineral spirits and paint thinner, which are combustible liquids. They have flash points around 105 degrees for those that understand flash point terminology. But they were packaging them in plastic. They had gone to packaging them in plastic containers. They had changed the classification of what they were storing, and what they thought were state-of-the-art sprinkler systems for protecting flammable and combustible liquids in metal containers is completely different with plastic containers. This also started some research projects on testing for flammable and combustible liquids in plastic containers and what kind of sprinkler arrangements you needed for that type storage. This fire started when a carton from a lift truck fell as it was being put into the rack. It resulted in about 8 to 10 gallons being spilled over the top of the lift truck and on the floor around the lift truck. A spark from the lift truck started the fire. It's believed that spark probably came from when the lift driver probably tried to apply the brake or tried to get off the truck and took his foot off the brake. What you will see, you commented about turning water off to the sprinkler system. What they will talk about is how they decided to turn the water off to the sprinkler system to avoid contamination of the aquifer. But by the time they made that decision, the roofs had collapsed, the fire had gone through the firewall and involved both sides of the building, and it was a total loss anyway. So it did not have a big effect in that. So.
Do you remember what you were doing in 1987? Well, for Daytonians, it was the year of a giant fire that changed safety forever.
Flames destroyed the Sherwin-Williams paint warehouse. They also threatened the city's water supply. Jordan Burgess spoke with the men at the center of the inferno whose leadership kept our water safe and clean.
The fire is still out of control, and we have a number of news crews on the scene. One of them happens to be Dave Calabro and his photographer, and these are the pictures right now of the site.
All these years later, the flames are still seared into their memories.
Biggest fire I ever see in my 33 years in this business.
But the raging inferno at the Dayton Sherwin-Williams warehouse 25 years ago isn't remembered just for what happened, but what didn't happen, and how it may have rescued the city from an even bigger disaster.
And he may be the only fire chief on the planet that became famous for not fighting a fire.
The warehouse is now a field, the only machine here a mower. But in 1987, it was like a paint-filled time bomb waiting to splatter. You see, because of decisions made decades earlier, the Sherwin-Williams warehouse was sitting on Dayton's well field.
In retrospect, probably wasn't the best thing.
People had warned about the danger for years, and all it took to set the city's worst nightmare in motion was a small spill by a worker on a lift truck.
And when he backed that piece of equipment out to get out of the way, that ignited the spilled product, and that was the start of the fire.
The plant had prepared for just such a situation. It had state-of-the-art sprinkler systems, but even they weren't enough.
That particular night and the way events turned out, I think those suppression systems didn't last probably a few seconds, and they were null and void.
The worker on the truck suffered burns to his legs, but thanks to a practice evacuation plan, everyone made it out safely.
You know, they had told us how fast it could go, and I just ran. When I seen it, I headed for the door.
Believe it or not, Dayton Fire Chief Glenn Alexander was actually painting at the time he got the call.
A neighbor had made a toy box for my daughter, and I was painting the thing.
When firefighters arrived on scene, they had hundreds of aerosol cans raining down on them. In the years afterward, they would be found on the nearby Kitty Hawk golf course and the roofs of buildings.
They were just rocketing. You see the bottoms blown out.
In this old video, you can hear them exploding.
It was like they were under artillery fire.
Aside from the paint can rockets, the fire was inching closer to other buildings. But Alexander knew he had a bigger issue at hand.
Let me tell you what our real problem is. You're standing on our biggest exposure.
Having been part of a well field protection task force and having talked with Water Department Director Bill Zilli and Environmental Manager Dusty Hall, Alexander knew the runoff from fighting the fire could pollute the drinking water.
Immediately in my mind, my whole thought process went for the well field.
So he made the toughest decision of his career and told crews to stop fighting the fire.
And I was bombarded with questions about, you're letting this thing burn down. And I said, yes, I am.
They're going to let this fire burn out. That's the whole idea, is let this fire burn out.
Unfortunately, firefighters weren't the only ones dumping water on the fire. The sprinkler system was still going. So the task fell to Bill Ford and another firefighter to go near the building and shut it down.
These aerosol cans are zinging by our heads, and he's saying, this is neat, you know. I said, let's just worry about getting in here and get this job done and get out, you know.
With the sprinklers off and no water being poured on the flames, the fire continued to burn for 6 days. The loss was in the range of $64 million. The 120 jobs there also up in smoke. But the well field was saved.
In this incident, as catastrophic as it could have been, there was never an operating public water supply well that became contaminated, ever. And no one would have ever imagined that that was possible.
25 years later, we went back to the site of the fire with those whose actions helped keep it from becoming even worse.
A lot of courageous decisions were made that night.
The impact of the blaze is still being felt today. It changed fire codes, making buildings safer. It also made people realize the importance of protecting well fields.
So what we learned from this was you can't engineer a facility with that kind of material to be safe in a place like this.
In the years following the fire, Dayton ramped up its well field protection practices and is now one of the nation's leaders in keeping drinking water safe.
People come here from all around the world to see how this drinking water has been protected. So it's a very positive story in the end.
But the men who made the difference that fateful night say those lessons of the past are only useful if, like the fire, they're seared into our minds.
Now, that fire led to reports by the Kennedy School of Government at Harvard and the U.S. Fire Administration, which compared the actions at the Sherwin-Williams fire to a similar one at a Swiss chemical warehouse. In that case, Swiss firefighters used water to put out the flames and contaminated the Rhine River. So you can understand the importance of the decisions made that night at the Sherwin-Williams fire. Reporting live, Jordan Burgess, 2 News.
That Rhine River fire that he's talking about was just about a year prior to this fire, and that's where it wasn't a sprinkler facility, and you got to understand the European method of protecting things. They're very big on firefighting and not so big on sprinklers systems, and so they just kept pouring water and water and water on it and really did a number on the Rhine River. All right, any questions so far? Mike?
Tony, could you describe how a fire system works and the design criteria of how many heads, and I know it varies, but really how many heads are really designed to hold?
Yeah, let's just keep it to that. When we design a sprinkler system, and even, let's take this room for example. We do not design for every head to operate in the whole building or even in a whole room. It's only designed for a certain number of heads to operate. Whether in a light hazard occupancy like this, it might just be 15 sprinklers. If the spacing's even greater on the heads, it might only involve 10 to 12 of those sprinklers. In larger facilities, might be 30 sprinklers. In some cases, we have very high designs that require maybe close to 50 sprinklers. Some new suppression systems out, they design it for 12 sprinklers to operate. So you are not designing for the whole building, every sprinkler in the whole building to come on. You're only designing your water supply and your pressure and your flows for that, whatever, whether it be 10, 12, 30 sprinkler heads to operate. And that's based on testing that we've done that says, you know, for that type of fire we anticipate, we will have controlled the fire or suppressed the fire with those 10 sprinklers operating or 12 or 30, whatever in your design, what we call the design area. So, is that good enough?
Once it exceeds that, what happens?
Once it exceeds that, we're in the overwhelmed area. You won't get, if you design for 12 heads to operate and now you're operating 15, you don't get the right pressure, you don't get the right flow, chances are you're not going to continue suppressing or controlling the fire if it's not out at that point, which that's why your extra heads are operating, because the fire's gotten bigger than expected for some reason or another. And that's when then the pressure and flow, it's not doing anything for suppressing or controlling the fire.
Is that what happened to Sherwin-Williams?
Sherwin-Williams, what we believe happened is that fire spread very quickly up the racks. It involved far more flammable and combustible liquid than anticipated because they were in plastic containers where previously they were in metal containers, and so the system became overwhelmed. Started stretching, it started involving aerosols. We've talked about already then the aerosol cans, how they rocket, and you heard them on that video clip. They're shooting all over. They're shooting a stream of flammable gas, flammable liquid, and they're going from this side of the room and starting a fire on that side of the room. If my fire started here, and I was designed for a handful of heads to operate, and now all of a sudden the fire starts over there and another handful of heads goes, and then it just keeps going, that's the system's overwhelmed then. Then you're just putting water on the fire and it's just turning the steam before it does anything. So, all right. I want to talk about flammable and combustible liquids. Everybody knows about flammable liquids. They come with red diamonds. Their flash points are below 100. There's also combustible liquids. They go all the way up. They can go up to, there can be combustible liquids with flash points 500 degrees, 600 degrees. In this picture, even though the turpentine says it's combustible, it's actually a flammable liquid. It's got a flash point of 95 degrees. It's a flammable liquid. The lacquer thinner is flammable liquid. The paint thinner is actually what we call combustible liquid. Now, the question I have is, do combustible liquids burn? Yes, absolutely. But I'm going to tell you a story from December 1993, Palm Beach County, Florida. It's in a retail home improvement store. It was Builder Square, which is, I don't think they're around anymore. I think they were the predecessor to Home Depot and Lowe's. We had a pair of stock boys doing display cut case of mineral spirits in plastic containers. And display cut cases, they cut the top of the cardboard carton off on an angle so they can display it. Now one stock boy took his knife, cut the top of the cardboard off, went in too deep, cut the plastic container, leaked about a half a gallon of mineral spirits onto the floor where they were working. The other stock boy told him, you better be careful cleaning it up. The one stock boy said, it's not flammable, it's combustible, it doesn't burn. He then proceeded to take out his cigarette lighter. He put it down to the spill on the floor once. What do you think happened? No, didn't go off. So he tried again. Still didn't go off. Third time, it flashed. Flashed the whole pool, went up the racks. They couldn't get the fire out. There was $3 million of damage to the store. It was so many sprinklers opened up. Actually, it's amazing that it wasn't a total loss, although the store never did reopen. So many sprinklers opened up in that store, and then there's a Kmart right next door that radiant heat went through the wall and opened up a few sprinklers in that store. And because it was December, they couldn't even, some of the Kmart people that were in the checkout line with their Christmas shopping wouldn't even leave, even though the alarms were going off in the Kmart building. He was prosecuted. I'm not sure what the final result was on it, but it's one of the classic all times. No, it's combustible, it's not flammable, it doesn't burn. Combustible liquids with flash points between 100 and 200 degrees, virtually the same as flammable liquids. Your California building and fire codes treat it the same. Where you, for those of you that store flammable liquids, and you're familiar with probably then storing flammable liquids in a cut-off room or something, if you also have combustible liquids with that flash point in the 1 to 200 degree range, they should be in that same room by the codes. So, all right, let's talk storage arrangements. Storage arrangements, including the height of storage, will have a major effect on the required pressure and flow of your sprinkler system. So if your facility was originally designed to store palletized storage, bulk storage, and now you're storing in racks, chances are your sprinkler system is no longer adequate. If your system was designed for a maximum of 12-foot high storage, and now you decided, well, you know, my roof is 24-foot high, so I think I can store to 20 feet. Chances are your sprinkler system isn't adequate any longer. This is that Central Garden Pet Supply fire from August 2000 in Phoenix. It's the one, I showed you another picture of this earlier. This fire overwhelmed the sprinkler system because their sprinkler system wasn't adequate for the height of the pool chemicals they were storing in the facility. Pool chemicals are typically oxidizers. They'll run in that, there's 4 classes of oxidizers. They'll be in the 3 lower classes, from the lowest hazard to class 1, 2, and 3, with 4 being the worst. This fire actually, because it generated so much chlorine and acid vapors in the area, prevented businesses, and they had to evacuate the area. I think they even closed down Sky Harbor Airport for the day, and a major roadway was closed. But the businesses and residents in that area were evacuated for 2 whole days. And if I'm not mistaken, there's still some lawsuits out there that aren't settled on this fire.
1.6 billion.
Is that what it's up to now? All right. All right. This one's the Biolab fire. This is the one I showed you earlier from Conyers, Georgia. This was May 2004. This fire overwhelmed the sprinkler system because nobody apparently realized that the sprinkler system was drastically under design. The building was used for the manufacture of appliances like refrigerators prior to Biolab's leasing the building for the storage of class 3 oxidizers, cal hypochlorite, which is one of your nasty oxidizers. So that required, to store cal hypo requires a tremendously greater pressure and flow from over appliance storage. All right, this one's going to be Magna Blend fire in Texas 8 months ago. I'm going to show this because I want to show, for those of you that do store flammable and combustible liquids, besides just knowing flash points, you also have to know if they are water-soluble flammable liquids or non-water soluble flammable liquids. Water-soluble flammable liquids, a water sprinkler system will work fine. Non-water soluble, the fire will float on the sprinkler water and spread all over the place. So you have to think about, do I need a foam water sprinkler system in that case? pay attention to as all the firefighters who had no clue what chemicals were in this building decided we'll just keep throwing water and water into the fire, into the building. They're throwing water and water in there. Watch as it rolls out, and that's an $800,000 fire truck that is going to disappear. The white stuff you're seeing is the steam. As the fire's floating on top of the water, it's turning the water to steam. That was the backup fire department, wasn't from the town. They were second or third in. I think it was a Waco, Texas fire truck. And town council, I had the opportunity to be in that area back in December. Met a guy that's neighbors on the town council there. Not too happy about what has happened to their $800,000 investment here. All right, so where do you go to? As I said, I do not expect you to understand all this. You're getting a minimal education in it, only so you can be aware of conditions that may have you thinking that maybe I should talk to somebody about, is my sprinkler system adequate? So who do you go to? I'm presuming none of you have in-house fire protection engineers that work in your company, so you got to go to an outside person.